Morning all, welcome for this lecture. Today we are going to solve the numericals on node analysis. Let's observe this numerical. They have asked find the current flowing through 7 ohm resistor in the network shown below using node voltage method. Okay, remember whenever they specify that current flowing through or voltage across something, then that element we should not supposed to alter. So here they have asked us to calculate current flowing through 7 ohm resistance. Observe in this entire circuit where is the 7 ohm resistance. Yes, here is the 7 ohm resistance. We not supposed to alter this. Okay, we should not alter that 7 ohm resistance and let it be keep as it is, and then we'll try to apply node voltage analysis. Okay, meaning of this one is we have to apply KCL, right? So let's see how to do this. First let's identify the number of nodes. Okay, so as we have discussed in earlier classes, this voltage source along with the resistance we are going to consider as a one branch. Okay, so at this point, okay, I'll take this as a first node because this one branch is connected, one independent current source is connected, one 3 ohm resistance is connected, and 4 ohm resistance is connected. So this I'll take as one node, and then next we'll be taking this one as a second node. Okay, because observe at this node 3 ohm resistance, 5 ohm resistance and 6 ohm resistance are connected. 3 branches are connected. Okay, another one is come to this. Okay, so this one is our one more node, which is third node. Okay, this is your third node. For third node also 4 ohm, 5 ohm and 7 ohm resistance are connected. Okay, and then last this one will take as a fourth node, and we'll be taking this one as a reference node. Okay, for this fourth node we have this branch 6 ohm resistance and 7 ohm resistance. This we are going to take as a reference, and for this will be voltage across this voltage at this node will be mentioning V0, and it is 0 volt. Okay, so remember one thing, how many nodes we have taken? 1, 2, 3. Okay, 3 nodes means 3 equations. 3 nodes means 3 equations, and each node at first node how many branches you have? 1, 2, 3 and independent source 4 branches are there. Okay, at first node 4 branches are there, means 4 factors, first factor, second factor, third factor, and equal to one independent current source. Okay, so for at first node 4 branches, and at a second node how many branches are there? 3 ohm, 5 ohm, 6 ohm, only 3 branches are there. Okay, and then at a third node again 4 ohm, 5 ohm and 7 ohm, there are 3 branches. This has to be well known with us. Okay, because we are going to write the equations based on this 3 nodes through so 3 equations we get. Let's solve that. Okay, so as you know, this is a V1, V2 and V3. This is your V0, which is equal to 0 volt. Okay, so this we have discussed, right? And then what is assumptions? What we are doing is branches we have to take. Okay, branches we have to write at one side, which is equal to current sources whenever you are applying KCL at each node. Okay, so assumed direction of currents are leaving the node because these are all resistances. Okay, 2 ohm, 4 ohm and 3 ohm are resistances. Okay, resistances, so those are all leaving the current, and this independent current source they have given, and it is shown which is entering. Okay, what is our thumb rule? Current in the at first we will be speaking at first node. Okay, V1, so this is your first factor, right? V1, apply KCL. when we are applying KCL, V1, this is a plus, so we have to take V1 minus, because what assumed direction is in this direction, what actually direction is, current direction is this one. So those two are opposite, therefore it will be V1 minus 10, okay, divided by 2. Okay, and second term will be taking this 3 ohm resistance. It is connected between V1 and V2. Therefore, this is the first factor plus second factor is second branch. Okay, V1 minus V2. Why V1 minus V2? Because you are at V1. Wherever you are, at which node you are, that voltage is dominating, you have to assume. So V1 minus V2 divided by 3 ohm plus this is for second branch. First branch got over, second branch got over, third branch. The third branch is 4 ohm and it is connected between V1 and V3. So it is V1 minus V3 divided by 4 ohm. Okay, and then last 4 elements are 4 branches are there, so which is independent current source, which is equal to, okay, these are about branches which all you have assumed is a positive, right? That's what this plus and this one is also plus. When you are taking equal to, that is independent current source. When you are taking independent current source, remember one thing, that if the current source is entering, then you have to take it as positive. Okay, if suppose this same current source is in this direction, opposite direction, leaving the node, then you have to take it as minus 5. Okay, hope it is clear. So now we'll apply same thing, KCL at a first node. Okay, these things you should remember, that at first node there are 4 branches. So 4 branches in that equation. In that first equation, you should have 4 branches. Okay, and at a second node, you should have 3 branches, 3 factors. Third node, you should have 3 branches, means 3 factors. Okay, this you should be knowing. Next, we'll apply KCL. Once you start applying KCL, right? So as you know, there are 4 factors. Okay, 4 branches: first, second, third, and fourth. Okay, and now apply for this at V1, okay, or at first node, apply KCL. So V1 minus 10, okay, V1 minus 10, right, divided by 2 ohm plus second one is connected between V1 and V2. So V1 minus V2 divided by 3. Okay, and next third branch is 4 ohm, V1 minus V3 divided by 4, which is equal to current source. We have to write current source which is entering, so we have taken plus 5. Okay, next thing is this is simplification. What we can do is V1 by V2, you can take on next step, that is V1 by V2 minus 10 by 2 plus V1 by 3 minus V2 by 3 plus V1 by 4 minus V3 by 4 equal to 5. You can take that step, intermediate step. So then what we can do is, let's take a V1 outside. When you take a V1 outside, there will be 1 by 2 plus 1 by 3 plus 1 by 4. Okay, and next in this case you have V2, so it should be minus V2 divided by 3. Next minus V3 divided by 4. Okay, last term is left out with minus 10 by 2, which is equal to 5. Simplify this by using calculator. Okay, 1 by 2 plus 1 by 3 plus 1 by 4, if you do that, you get 1.08333. Okay, minus 1 by 3 is 0.333 V2 and minus V3 by 4 is minus 0.25 V3. 10 by 2 is 5, so minus 5, which is equal to 5. Send this 5 to this side, so it will be 10. So just to write systematically, it is 1.0833 V1 and this is minus 0.33 V2 and it is 0.25 V3, which is equal to 10. Let's call this equation number 1. As we said, how many nodes are there, those many equations you get. Okay, those many variables also you get. So apply KCL at a second node, which is at this part. Okay, apply KCL at this point. Remember how many nodes are there? Sorry, how many branches are connected? First branch, second branch and third branch. Let's write the equation at this. We can write, first we'll take this one. Okay, it is you are at V2, so you are at second node, so V2 will be dominating one. First we'll take this, that is V2 minus V1 divided by 3. This is first factor, plus second factor is 5 ohm. It is connected between V2 and V3. So V2 minus V3 divided by 5. So this is second factor. Third factor is this one, that is 6 ohm resistance. It is connected between V2 and V0. So it is V2 minus V0 divided by 6 ohm. Anyhow V0 will be 0. Therefore I am not going to consider that. Is it clear? Alright. Next. So these three are the factors at left hand side. So what is equal to? Equal to any other independent current source you have at a second node? No. Therefore it will be equal to 0. Right? So like this you have to write. Observe the network and write the equations. Observe. So at a second, V2 minus V3. Okay, you are at a second node. Therefore V2 is greater than V1. You are assuming. So V2 minus V1 divided by 3. Next plus V2 minus V3 divided by 5. That is this one, 5 ohm resistance which is connected between V2 and V3. So V2 minus V3 divided by 5 ohm. Next, last one is 6 ohm. That you can take V2 minus V0, or you can directly write V2 by 6. Anyhow V0 value is 0 volt, equal to 6. Sorry, equal to 0. So here in this case what you can do is V0, you can take V2 by V3, V2 by 5, V2 by 6 aside. So what you can do is V2 if you take outside, 1 by 3 will be remains, and then 1 by 5 and 1 by 6. So simplify this, you get one more terms, that is minus V1 by 3, and you get one more term, that is minus V3 by 5 equal to 0. Simplify this, you get a 0.7 V2, 0.33 minus 0.33 V1 and minus 0.2 V3. Okay, so just what we have to do is simplify this term, means rearrange the term. First I will write V1, next I will write V2, and then next we will write V3 which is equal to 0. This is your equation number 2. Okay, this is your equation number 2. You have got first equation, second equation, third equation we require. For that we have to apply KCL at V3. Okay, or third. Okay, apply KCL at third node. That is, there are 3 branches, 1, 2, 3. So therefore 3 factors will be there. We'll be applying here. Observe, you are at V3, so V3 will be greater. Okay. So now first factor, that is V4 ohm, which is connected between V3 and V1. So V3 minus V1 divided by 4 ohm, first factor, plus V3 minus V2 divided by 5. V3 minus V2 divided by 5. Next, last one is I will take V3 divided by 7. Okay, equal to 0. Actually it is V3 minus V0 divided by 7. Since V0 is 0, we will be taking it as V3 by 7. There are 3 factors, 1, 2 and 3, which is equal to 0. Just simplify this. Okay, you can simplify this. Observe, V3 minus V1 divided by 4, V3 minus V2 divided by 5 plus V3 equal to 7. So simplify this. What you have to do is, let's take V3 outside, 1 by 4 plus 1 by 5 plus 1 by 7, and you get a minus V1 by 4 minus V2 by 5 equal to 0. Simplify this, you get 0.5928 V3 minus 0.25 V1, 1 by 5 is 0.2 V2 equal to 0. Just write, rearrange the terms, V1 first, V2 next and V3 next. So that is minus 0.25 V1 minus 0.2 V2, 0.5928 V3 equal to 0. So this is your third equation. Once you have got all 3 equations, 1, 2, 3, by solving 1, 2, 3 equations by Cal C, you get V1 is equal to 14.1948 and V2 equal to 9.36 volts, V3 is equal to 9.146. Okay, this is not sufficient. What they have asked in the question is, They have asked us to calculate current through 7 ohm resistance. Here it is. So let's calculate what is the current flowing through that resistance. So since we have taken this as a V3, so current through this one will be V3 divided by 7 ohm, right? Current flowing through 7 ohm will be equal to V3 by 7, okay, by seeing this branch. So that we have to write. Current through 7 ohm resistance will be I7 ohm. I7 ohm means current through 7 ohm resistance will be equal to V3 by 7. You know V3, we have calculated it 9.146 divided by 7. So that you simplify, you get 1.307 ampere current which is flowing through 7 ohm resistance. Okay. Hope you have got this. Thank you.